Here we are, Exponents and Radicals, Lesson 4, which is Entire and Mixed Radicals, Part 2. So now I believe we're going to be going the other way, converting mixed radicals with an index of 2 to entire radicals. So now we're working the other way around. So just as a quick review, last lesson we were looking at things like this, the square root of 8, and we were converting this to a mixed radical, which by one process would be the square root of 4 times 2, which is the square root of 4 times the square root of 2, which is 2 root 2. Or another way is we looked at the prime factorization. Square root of 8 is the square root of 2 times 2 times 2. This is square root, so we're looking for pairs. This 2 comes out, and I'm left over with this lonely 2, square root 2, same place, okay? Either or. Now we're going to be working backwards. Okay? We're going to be going from our mixed radical to our entire radical. Okay? So we have to understand the process, the reverse now. Complete the following to convert 3 square root 14 to an entire radical. Okay? So our mixed radical is 3 square root 14. We knew that in order to get to this place with the 3 on the outside, that on the inside, that had to be 3 squared, right? 3 squared. 3 squared is 9, so that's 9 times 14. Right? So the square root, 3 square root 14 as an entire radical is going to be 9 times 14, which is 126. So mixed radical, entire radical, or pure. Sometimes it's used, pure. So you just kind of have to remember that idea. Well, what index am I dealing with? In this case, it's a 2, so it's always, I think, for the most part of what we're doing. No, there's some 4s. So whatever that index is, we raise that coefficient to that index when we put it back into the radical sign. Okay? So let's look at example 1. Convert 2 root 5 into an entire radical. So again, this is square root. So I'm going to raise that 2, this 2, to the square root index times 5. That is all going to be underneath the radical now. And then I just expand. Square root of 4 times 5, which is the square root of 20. Okay. This is for square root 7. Square root 7. So I'm going to put this back into the radical by saying, well, I've got to square that when I put it back in, times 7. 4 times 4 is 16. 16 times 7 is 112. Question B. 10 root 6. So this is 10 square root 6. To put this back into the radical, it's going to be 10 squared times 6. 10 squared is 100 times 6. 100 times 6, 600. And again, you should be able to check these on your calculator fairly easily. Okay? You can punch in 10 times the square root of 6. Should give you some kind of decimal number. You could punch in the square root of 600, some kind of decimal number, and those two numbers should be the same. So now we just start to get a little bit more complicated, that's all. This is 3 over 2 square root 8. I know that if I'm putting this back into the radical, convert the following mixed radicals to entire radicals. If I'm putting this back in, remember this was square root, so back inside is going to be 3 over 2 squared times 8. And then I expand. 3 over 2 times 3 over 2 times 8. 3 over 2 times 3 over 2 is 9 over 4 times 8. 9 over 4, 9 times 8 is 72 over 4. 72 over 4 simplifies and reduces to 18. 18. Done. 0.4 times square root 50. Again, this is squared. This is squared. And let's work this out and see what happens. Square root of 4. So this is going to be 0.4 squared on the inside times 50. 0.4 squared is 0.4 squared is 0.16. As I quickly check on my calculator, 0.16, 0.16 times 50, 50, not 5. And when I multiply that by 50, I get 8. Question B. C. Negative square root 7. Negative 5 times square root 7. So this is where you have to remember, this is an even root. So no matter what I do, this negative has to stay outside my root sign because I can't have that negative go into my root sign. So it always has to stay on the outside if this is an even root. 5 squared is on the inside, times 7. 5 squared is 25, times 7. 25 times 7, 25 times 7, 175. That's a 1 and a 7. Now, all we do is now we start playing around with that index. Well, now maybe that index is 3 or more, right? So instead of a squared, it's cubed. The process is exactly the same. Complete the following to convert 1 over 2 cube root 80 to an entire radical. Well, if 1 over 2 cube root 80, in order for that 1 over 2 to come out, we have to raise it to that power of 3 to put it back in. 1 over 2 cubed. Okay. Then we expand. 1 over 2 times 1 over 2 times 1 over 2 is equal to 1 over 8 times 80, which is going to be equal to 80 over 8, which is equal to 10. Don't forget the cubed. Cube root 10. So the process is no different when that radical is different other than a 2. We just put more stuff back in, right? So 2 fourth root of 3. This is going to be 2 to the power of 4 times 3 on the inside now. Well, 2 to the power of 4 is 16. So don't forget this is a fourth root. 16 times 3, which is fourth root of 48. Question B. Negative 4 cube root 7. Now, this is an odd root, so I have a choice of what I can do with the negative. I can leave it on the outside, or I can put it on the inside. So we leave it on the outside, just like we did with square root, or I put it on the inside by bringing it in with my cube. So I'll do it one way on the outside. I'm going to leave my negative 1 by itself. I'm going to put that 4 cubed back in, times 7. Negative 1 cube root 4 cubed. 4 times 4 is 16 times 4 64. 7. 64 times 7 is 64 times 7 448. Done. That's with the negative on the outside. And really it would be written like this. Negative cube root 448. It's implied that 1 is there. We just never write it. And then I'll switch colors to, let's say, blue. And I'll put the negative back inside, which means I'm going to take this whole thing and raise it to that odd power. Negative 4 cubed times 7 is on the inside. Well, negative 4 times negative 4 times negative 4 is negative 64 times 7. It's 3, which is equal to negative 448. So either the negative's on the outside or the negative's on the inside. With a negative one, you can choose. It doesn't matter. Both are correct. Question C. Again, we're going to put this 2 to the 5th cubed, 2 over 5 to the 5th, 2 over 5 cubed times 100 back into our radical. We're going to expand the 2 over 5. 2 over 5 times 2 over 5 times 2 over 5 times 100, technically over 1, okay, which is going to give me 2 times 2 is 4 times 2 is 8, 800 over 5 times 5 times 5, 125. And then you would reduce that fraction. I know they both divide by 25, probably would be an easy one. So this is going to be 5 below and 32 on top. And that's where you would leave it. But it does have to be reduced. 3, 4th root 2, again, because this is an even root, the negative has to stay on the outside. I'm going to put the 3 to the 4th back on the inside, and that's going to be times 2. Well, 3 times 3 times 3 times 3, 3 to the power of 4, 81 times 2. Oh, that's 4th root. Don't forget the 4th root. 81 times 2, 162. And then, of course, we can play with variables too, right? So there's some variables coming. Convert the following mixed radicals to entire radicals. This is square root. So this is back inside going to be 2 squared times x cubed. Well, 2 squared is 4 times x cubed, and you'd be done. A squared times a, again, this is squared. So going back in, it's going to be a squared squared times a. Well, a squared squared, power to a power rule, you multiply. That's a to the 4th times a. And because those have the same base, I can go a to the 5th. I would add that 1 to the 4. Question C. X to the 5th times xy. X to the 5th times the square root of xy. So that x to the 5th going back in is x to the 5th all squared times x times y. X to the 5th squared is x to the 10th times x times y. And again, I can combine those x's. 10 plus 1, x to the 11, y, square root. 3xy cubed times the cube root of 2z to the 4th. So this is cubed. So now this 3xy cubed, oh, wrong y cubed, sorry. Xy cubed all gets cubed, putting it back in, times 2 times z, 4. That's all under the cube root sign. Now, power to a power tells me that I have to multiply this power to this 1 that's here that's never written, to this 1 that's here that's never written, and to this 3. So this now simplifies to, next step, 3 cubed x cubed y 9 times 2 times z 4. And then I have to simplify and expand. I'm going to combine, I'm going to multiply this out and multiply it by the 2. 3 times 3 times 3 is 27 times 2 is 54. No other variables can be combined. X cubed y 9 z 4 all cube rooted. Which takes us to the end of lesson 4. Again, check the Exponents site or whatever other tracking thing we're doing to figure out what questions are getting assigned. And we'll see you next time.